So now we're doing section 3.5, preview activity 2. So here for number 1, we let n be a natural number and a and b be integers. So write the definition of a is congruent to b modulo n, which is written like that. Okay, so a congruent to b mod n. Well, the definition of that is that n divides a minus b. Okay. Use the definition of divide to complete the following. When we write a is equivalent to b mod n, we may conclude that there exists an integer k such that there exists an integer k such that n equals k times a minus b. Okay? Write the reflexive, symmetric, and transitive properties of congruence. What reflexive, symmetric, and transitive? So, reflexive. These are really good. This would have been a really good classroom activity. The preview activity, hopefully you attempted it before watching this video. Reflexive. So, reflexive is that a is equivalent to a mod n. So, things are always congruent to themselves. Symmetric. Symmetric is that a is equivalent to b mod n implies b is equivalent to a mod n. Okay, transitive. Okay. Transitive is that if you have a is equivalent to b mod n, of course I'm being lazy here, I'm not like defining my variables like I would have to in a written out homework. A is equivalent to b mod n, and b is equivalent to c mod n implies that a is equivalent to c mod n. Okay, it's transitive. Explain why 17 is equivalent to 5 mod 6. Okay, why is 17 equivalent to 5 mod 6? Well, that's because 17 minus 5 equals 12, which is 2 times 6. Well, you can't see that, sorry. Why is 17 equivalent to 5 mod 6? Because 17 minus 5 is 12, which is a multiple of 6, 2 times 6. So hence 6 divides 17 minus 5. Okay, if x is an integer and x is equivalent to 17 mod 6, what conclusion can be made about the integer x using the transitive property of congruence? Then x is also congruent to 5. So x is congruent to 17 mod 6. Transitive property gives us that x is equivalent to 5 mod 6. Okay, find an integer. Oh wait, I'm almost done here. Okay, no, we finished that. So the last part, 2c. Find an integer r such that 16 squared is equivalent to r mod 6, and r is between 0 and 5. Is there more than one such integer? Find an integer s such that 5 cubed is equivalent to s mod 6. Is there more than one such integer? All right, well, 16 squared modulo 6. 16 squared. You can put it in your calculator, but it's really just, you could take 16 is 2 times itself 4 times. So if you just multiply 16 squared would be so multiplied by 2 4 more times. So 32, 64, 128, 256. Okay. Now, what remainder do you get when you divide this by 6? Well, this number is even, but is it a multiple of 6? No. Do you know how to check how things are multiples of 3? You add up the digits, and that's a multiple of 3, then it's also a multiple of 3. So here, I have the digits, that's 7, 6 is 13, 13 is not a multiple of 3. The 12 is a multiple of 3. So the 255 is not even. So then this is equal to 252 plus 4. Okay, and then 252 is a multiple of 6. Let's pull out the handy dandy calculator. Where did I leave it? There we are. So our handy dandy calculator says 252 divided by 6, 42. So that means that's your remainder. 4 is the remainder. So is there any other remainder? No, because if you look at our example from the last one, you were always adding and subtracting 4 there, and here you're adding and subtracting 6. So no, there is no other number. And then 5 cubed. 5 cubed equals 125. Modulo 6. So this number, 3, 5, so 123. So 120 is a multiple of 6. So this is 120 plus 5. So then that's the remainder. And so then that's the only remainder between 0 and 6, 0 and 5. So that completes preview activity 2.